What is a $1,000 a month rule for retirement? It basically suggests that for every $1,000 of desired monthly retirement income, you will need approximately $240,000. Folks, what we do on this channel is actually set up spreadsheets that kind of run numbers to show you how these might have worked out. And what we do is use numbers for the last 100 years for the S&P 500, which includes the depression type returns, because we want to kind of look at worst case scenarios here. So again, what we want to do is look at this question. Say, for example, you need $4,000 a month in desired monthly retirement income, realizing you probably need a little bit less once you reach retirement. A lot of people recommend 80%. But let's just say you need $4,000 a month. So what we want to do is set up a spreadsheet and show you how that might work. Now, $4,000 a month, if you got $2,000 a month, first of all, let's go ahead and choose $4,000 a month here. This is one of the spreadsheets that we use. So $4,000 a month. Let's say you're getting $2,000 a month from Social Security. Again, that's a biggie, what you're going to get from Social Security, which means you're going to need $2,000 a month from your nest egg. Now, it says here for each $1,000, you need approximately $240,000. So if you need $2,000, you would need twice that. So let's go ahead and run the numbers. $480,000. That's our beginning balance. $480,000. What we want to do is run the numbers for every single year for the last 100 years from 1925 on. That's, as I update this, it's going to show us what you're going to have after 10 years, after 20 years, and after 30 years, given the returns for each of these different time periods. Right now, I've got the year 2000 showing. You can see that would have been a problem because of sequence of returns risk, because those first 3 years were down years. You would have a problem withdrawing $2,000 a month from this nest egg. Now again, that's a 5% withdrawal rule. That's what everything is based on right here. They said this would be 5% withdrawal rule, a little bit above the 4% rule. So we're just running at 5% to see how often this will work. Now, first thing we need to realize, you're probably not going to leave it all in the S&P 500, which is the numbers that we use there. We're going to go and do a 60-40 asset allocation. 60% staying in the S&P 500. 40% going over to a liquid account over here, that when the market's going down, you can take these kind of funds out of a cash reserve account, the liquid account, rather than touching this, because that's already being knocked down. You don't want to sell in a down market. So let's go ahead and update this and see if this, right now we got a 6% failure rate. In fact, I'm getting ahead of myself here. Let me show you the graph there. In the last 100 years, the only problems you would have, even leaving it 100% in the S&P 500, were 1929, 30 along in there, and also the year 2000. And again, that makes sense because we had the down decade here, but we also had the down decade right here. So let's go ahead and update this. Right now we got a 93.8% success rate, but let's see if this improves by going to a 60-40 asset allocation. In other words, not leaving it all in the S&P 500, but putting 40% over here. See if this 6% changes. Well, it just went down to 5%. So in other words, the problem with it is these initial years right here were such problematic years that even changing our asset allocation probably doesn't help a whole lot, unless, of course, you go to 100%, get 100% completely out of stocks. But let's go back up here. Here's something else you could do and see if this changes much. Instead of taking, I'm giving a 3% COLA, by the way, going down through here. Instead of a 3% COLA, after good years, we do 3% COLA. After down years, let's just take a no COLA at all. Let's just do 3%. So, and let's see how this changes this right here. Again, a 95% success rate is very good. But we're just kind of running the numbers here to see how this rule of $1,000 a month actually would work out. Look at that, folks. Just changing to a no COLA after negative years, and you have a 0% chance of failure using the numbers for the last 100 years. Here's the actual graph. Yeah, it's getting low around the depression years and getting low around the year 2000, but you would not run out of money. This is after 20 years. Now, if we do it after 30 years, we got some problems here. In fact, let's go back up to 1929. Even using the returns from the year 2000, looks like you're running out of money just after 20 years. So it would last 20 years. Same is true with the 1929 and 1930 numbers. Let me go up here to show you 1929 numbers. you get down to 18,000. And 1930 numbers, you're down to 80,000. It might last 22 or 23 years then. But folks, we just want to look at this. I just saw this and I want to run the numbers. Let's say, for example, you have, it shouldn't make any difference. If you need 5,000 a month, that would be 3,000 difference between what you get in Social Security. Again, we're just using round offs here to make it easy. So in other words, if you need 3,000 a month coming from your nest egg, then you'd have to take 3 times the 240, which would be 720,000, leaving everything else the same, 720,000. Doing the 60-40 allocation, doing a 3% COLA, except after negative years. After negative years, you don't give yourself any kind of a COLA. You just get the same you did the year before. How does that affect anything? Keeping to this 5% withdrawal rate, which is what everything's being calculated on. The 5% withdrawal rule. Watch what happens when we go to... These numbers really don't change, because all you've done is change it by a multiple. This was changed by a multiple from 2,000 to 3,000. This was changed accordingly. So the numbers basically stay the same, which is just simple math. Folks, we just want to run the numbers to see how accurate that means. A lot of people say to go with the 4% rule. I just recently saw somebody said, no, you can go to 4.7%. It looks like in this case, most every case scenario, if you do this COLAs, if you adjust those after negative years, looks like you have a 0% chance of running out of money using data for the last 100 years. So this 5% rule really looks like it can work for you using this rule right here. $1,000 a month. For each $1,000 a month you need an income, you need approximately $240,000. Now, obviously, if you needed $4,000 after you take into account inflation, then you are going to need basically $1 million, which is everybody tries to reach that goal. And most people don't. But the thing is, you don't really need that unless, of course, you need $6,000 a month, because that would be what $6,000 a month would be right here. Can get it to stop. $6,000 a month. Still getting $2,000 from Social Security. You need $4,000 a month now, so then you would need $960,000. This is showing you how this rule holds true. And of course it does, because all you're doing is changing the ratios. We update this, it'll be 0%. It'll be all these numbers are basically the same, except increased by the corresponding ratio. Just to show you here, 0% of the time. See, 0% of the time, the same two ones showing up here. Same kind of graph. Just showing you. So it looks like this is a good rule in almost every case, especially if you just need your money last 20 years, and only a few percent of the time in the last 100 years, this 5% rule would not hold up. And those were 1929, 1930, and around the year 2000. But again, that's if you don't take a COLA after negative years. In every other scenario, it looks like you'd be in great shape. Folks, that's what we do in this channel. We just love running numbers for people. We love setting up spreadsheets. We love seeing what's being talked about in the financial channels. It looks like this $1,000 a month rule for retirement is a rough estimate of what you can use, but don't forget to take into account Social Security, what you're going to get from that. But please share this channel with others. Let other people know about this channel. Let them know there's a channel out there that'll set up spreadsheets, run numbers, and look at some of these rules that are being put out there and actually run numbers. What would have happened using that rule over the last 100 years? Again, thanks for watching. Please share the channel and please like the video. And again, thanks for watching.